Hello, hello, hello. Okay, time for video number 2. This is a quick video which is going to be on redirecting in the shell. Now you probably know a lot of this already, but it's not a bad idea for me to go through things precisely and a little more slowly than normal. So in the shell, there are 3 different ways you can do redirection. You can use a greater than sign, which means redirect standard output. There's a less than sign, which means redirect standard input. And then there's the 2 greater than signs, which says redirect standard output and append. Okay, and then I need to spell standard correctly. Okay, so let's just explore a little bit about how this works. So I've got a file here in F1, okay, which just says this is F1. And so if I say cat F1 to F2, that's just going to take standard out and put it into F2. So now when I cat F2, it's going to say this is F1. If I say cat F1 and append F2, now when I cat F2, you'll see 2 of them. Okay. Redirecting standard input, I can say cat redirect standard input from F1. There we go. Just going to print that out, and obviously you can do both of these on the same command. F2, and that ends up being the same thing. Okay, nothing too exciting. The shell, when it sees the redirection signal, so when it sees the less than or greater than sign, it pulls that and the file name off of the command line, which is why in your argc argv, if I do cat F1 to F2, in your argc argv you only see this part. The shell strips this out before creating the argv array that gets sent to your program. You can put them anywhere too. You could say F2 cat F1, works just fine. Okay, same thing. You could say F1 cat, and it's going to work fine that way. Okay, all of those are pretty straightforward. Okay, now if you recall, there's standard in, standard out, and standard error. Different shells let you handle standard error in different ways. Now I'm just going to talk about the Bourne shell, which is also the semantics in Bash, which is pretty ubiquitous, so it's not a bad thing to talk about. So in Bash, you have syntax where you say, let's say I say cat F1. Now if I say a number and then greater than sign, what that means is take whatever is in that file descriptor, so file descriptor 1 is standard out, and then put it into a file. So if I do that, that's the same as doing it without the 1, because it's going to redirect standard out to F2. Okay, and there is F2. And let me also, so I'll be consistent with the lecture notes, I'm going to change my command. So instead of saying cat F1, I'm going to say cat F1 and F3. Now you're going to notice F3 doesn't exist. So if I say cat F1 and F3, then what I get are 2 lines. I'm going to get F1, and then I'm also going to get an error string, which cat created when it tried to open F3, and the open failed. Okay. In terms of file descriptors, this goes to standard out, and this goes to standard error. And standard error is file descriptor 2, standard in is file descriptor 0. Okay? But since by default both standard out and standard error go to the screen, you see both of them on the screen. Now, if I did this and redirected standard out to F2, now what's going to happen is the error string is going to get printed on the screen, okay? And the non-error string is going to get put into F2. Now, since standard error is file descriptor 2, we could redirect each of these separately. So if I say cat F1, F3, have standard out go to F2, and then let's have standard error go to F4. Now I have no output. When I look at F2, I get the standard output, and then if I look at F4, I get the standard error. Okay. Okay, sorry, just double checking here. Okay, these commands are processed from left to right, and you can do multiple specifications of, for example, standard out. So I could say cat F1, F3, have the output go to F2, and then have the output go to F4. It's actually legal. You'll notice the error string never got redirected, so the error string is printed out, and then F2 will be empty because it was created and truncated, but then when we redirected standard out again, then it went to F4, so F4 will actually have the output. Okay. Can you redirect standard input multiple times? Depends on the shell. I don't think there's a good reason to do it, so don't do it. In fact, I'm not sure if there's a good reason to redirect standard out multiple times either, but there you have it. Okay. Now, the shell creates its files, the redirection files, before it runs the executable. Okay? So if I say, suppose I take a look at F2, it needs to have something. So here, copy F1 to F2. Okay, and now I say head F2 and put the output into F2. Okay, I can even say cat F2, put the output into F2. Okay. If we get nothing, and then we cat F2, we have nothing, and that's confusing. But what happens is that even though F2 has some bytes here, when I say cat F2 and redirect to F2, it opens F2 for writing first before it executes the cat command. So it's opened F2 for writing, F2 is truncated, so when cat gets to cat F2, F2's empty. So now it takes the empty file, cats it, which is empty, and puts it in F2, which remains empty. Okay? It's something you should pay attention to because if you don't know to look for it, you can get confused by that one. Okay. All right. Now, let's go up to this specification here where we said, oh, that's a good one. All right, we said cat F1 and F3. F3 doesn't exist, so we'll get an error string. Have standard output go to F2, standard error go to F4. Okay, cat F2, that's going to be the standard out string. Cat F4, that's the standard error string. Now, let's suppose that I would like to have standard out and standard error both go to the same file. The way that works is here, when after the greater than sign, you can put a ampersand and a number. And what that says is have standard error go to the same file descriptor, or go to this file descriptor. So file descriptor 1 is going to F2. Okay, and now what this says is have file descriptor 2 go to where file descriptor 1 is going to. So what that's going to do is that's going to have standard error and standard out both go to the file F2. Okay. If we did them in the reverse order, the shell executes everything from left to right. So let's suppose we do these in the reverse order, and we say 2 and 1, F3, and then F2. Now what's going to happen is standard error is going to go what standard out is going to, okay, which currently is the screen, and then we redirect standard out and say standard out's going to F2. So what's going to happen is we're going to get the error string here going to the screen, which is what standard out is at this point, and then standard out is going to go to the file F2. So there's our error string to the screen, and then if we look at F2, it should have the standard out string. Okay? So you could, in theory, do something like the following. This is not the best way to do it, but if you said, have this go to F4, have standard error go to standard out, which is going to F4, and then redirect standard out to F2. Now what that does is that has standard error go to F4, and standard out go to F2. Cat F2, that'll be standard out. Cat F4, that'll be standard error. I have a big one in the lecture notes. I didn't prepare it, so let's just walk through it. In the lecture notes I say figure it out yourself, but can't hurt for us to work through it. So I'm going to cat F1 and F3. I'm going to take file descriptor 3, put it to the file F2. Now that's going to open file descriptor 3. File descriptor 3 is normally not open in your process, but by doing this, the shell will open file descriptor 3 and have it go into the file F2. Now I say 1 goes to F5, so now standard out's going to F5. I say 2 and 1, okay, so that means file descriptor 2 is going to F5. Okay, so standard out here is going to F5, and file descriptor 3 is going to F2, although nothing's happened to file descriptor 3. And then the last thing I do is I go 1 and 3. So now what that's going to do is that's going to have standard error go to F5, and standard out is going to go to F2. It also has a byproduct in my program that file descriptor 3 will be open in my program, which it normally is not. Okay. So here, so when we cat F2, that should be standard out, and if we cat F5, that should be standard error. Yeah. Okay. Now let's take a look at a program. So this is in bad code. I don't think it's really that bad code, but whatever. Give me a comment. Okay, so what do? I have a string that has hi in it. I have an integer and a file descriptor, and then what I do is I just write to file descriptor 3. I don't know if it's open or not, okay? But I'm going to write to it. Nonetheless, if it's closed or if it's not open for writing, this will return -1, okay? So I'm going to go ahead and print that out, but if it exists, it's going to work, and it will print out strlen of that, which is 1, 2, 3, 4. Okay? Then, if it failed, then it is a p-error statement. So that's going to go to standard error, okay? And then it returns. Okay. So let's just run this. There we go. Okay. Now when you run this, file descriptor 3 is not open, right? So that means the write fails. We get -1 and we get the p-error. Okay. Now let's try it again. But here what we'll do is we'll redirect file descriptor 3 to F5. That's going to open file descriptor 3, and now the write call will succeed. Right? And see it prints out its return value, which is 4. And if I cat F5, I should see hi. Okay. Lastly, let's suppose I do, and I do 3 and 1. Now what that's going to do is that's going to open file descriptor 3, have it go to where file descriptor 1 is going to, which is to the screen. So I'll get my hi to the screen here, right? And the 4. And we could do another thing. Let's run it without anything, and we'll reduce file descriptor 2 to F4. Now what's going to happen? The -1 gets printed to the screen because file descriptor 3 is not open, and then the p-error is going to go to file descriptor 2. So if I cat F4, I should get the result of the p-error. Okay. So hopefully this helps you navigate A, thinking about file descriptors, and B, thinking about shell redirection and things you can do. Now the last piece of code I have, this is something that I have done, but I'm not going to ever admit that I do it. Okay, here's the following. So what I have here is I've just got a bunch of procedures, print a bunch of blah blahs, make more procedure calls, right? So what I'm basically doing is showing a giant spaghetti mess of procedure calls. So this is my program, which is a giant spaghetti mess of procedure calls, and I got an error in it. And I want to find the error. And the problem is that I'm doing all these printouts, and it's hard for me to find my error when I'm doing a printout. So what I'll do is when I catch my error, I'll catch it. Here I'm just putting it into a string. We should call snprintf. I should fix that in the lecture notes there. snprintf. That's safer. Okay. And then I just write it to a random file descriptor that I know normally isn't open, like file descriptor 9. Okay. So when I run it, normally everything works just fine and it prints out a whole bunch of blah blahs. There is a point at which it gets to this part of the code, but when it tries to write to file descriptor 9, it's not open, so the write call fails and returns -1. No harm, no foul. But if I wanted to actually look at my error message, then I can run this and I can say 9 temp.txt. And now when I cat temp.txt, right, I've got my error messages all printed in there. So this is a nice thing to do sometimes when you're debugging, and you don't want to deal with the complexity of GDB, and you just want to figure out, get some error messages in a piece of complex code. This is actually not a bad trick to have up your sleeve. Just use an unused file descriptor and then open it in the shell. Okay, I know that was a short lecture, but I'm hoping it's been an informative lecture so that you learn a little bit about redirection, file descriptors, and Unix. All right, have good weekends.